The forensic process. The short course you're about to have will cover the forensic process for hard drive media. Other courses in this class will cover multimedia cards, cell phones, tapes, and a variety of different items. The forensic process basically includes duplicate and preserve, examination, recovery, analysis, the report, and then the disposition. And if you think about the chain of evidence, it follows suit almost line by line with those same 5 items. What is duplication and preservation? Well, duplication is faithfully duplicating every user accessible data object from the source media to the duplicate media. In other words, you should be able to recreate the original source media in its original format and form. That would be like taking a photocopy of a document. You have the original, but you have a duplicate that is an identical copy. Every little byte and bit on one is in the same position and form on the second, or its copy. So what do we mean by examination and recovery? Well, there's 6 main examination areas, and they're known as the host media environment, the host media data, partition space, both allocated and unallocated, as well as non-partition space. And you will see this on any type of storage media for digital data, be it a floppy, be it a thumb drive, an SD card for a camera. They all will have the same 6 main examination areas. I know, based on some prior classes, there are some other areas on the hard drive that are known as service areas or reserve areas. HPA is a good example of that. But remember, we use the term user accessible. The service areas and reserve areas are not normally accessible by a user on a day-to-day basis. And they usually don't come into play in the forensic process. To access those areas, it takes a special program or custom programs to write into those areas. And sometimes it even takes hardware to write into those areas. So what is host media environment? Well, this is the physical space surrounding the space where the media is contained during its use. For example, the computer that the hard drive came from. What was its date and time in BIOS, etc. It may be the tape drive was contained inside a tape storage vault, inside a cabinet, inside a room. So what is host media data? This is the data contained in the actual media to be examined and not the data on the media. For example, on a hard drive, it would be the electronic serial number that comes from the BIOS, the features that are enabled in the firmware revisions. On a floppy disk, it would be the date code that is written on the floppy or the lot number. On a tape drive, it could be the label and the serial number on the tape itself, but not the actual data on the tape. So let's talk about partition space. This is a logical grouping of data storage blocks on the media that the operating system is using and will recognize. Such as on a hard drive, it's sectors on a hard drive. Within this partition space, you can have both allocated and unallocated space. And what we mean by allocated and unallocated is that those sectors are allocated to a file, a specific file. Unallocated means the space is free and ready to be used and allocated to a file. What is allocated space? Well, allocated space is data storage space assigned by the operating system to a specific file or specific data that is being tracked by the OS. Space that is allocated is not available for use to store other data. In other words, as you create a file on a hard drive, the OS will go out and allocate sectors to that file. That would be considered allocated space. Allocated space is created from unallocated space. Unallocated space is not assigned right now to any specific data or for any data being used by the operating system to store any data. By default, non-partition space is also unallocated. However, to be used, it must first be partitioned. So, reiterating both allocated and unallocated space, all space on a hard drive when it's first put on there is considered unallocated because it's not assigned to a specific file. Once it's assigned to a specific file, it becomes allocated space. Now, allocated space can become unallocated space when you delete a file. You have now freed up those sectors and said, hey, these are unallocated and can be reallocated again at another time. Non-partition space. Technically, it's storage space on media that is not assigned to a local grouping recognized by the operating system. It's available for use, but first it must be partitioned in order to be used. You can think of that about pages in a book. You have a book and you have all these white pages, but they're all loose. So now to partition them, you group them together, bind them, and now they're what we now look at as a book or a partition ready to have data written on the individual partition space. So now that we know the different areas in which we collect data and where we collect data from, we now place them in a queue to be analyzed. That is what we're going to discuss next. So now we go on to analysis. Data is reviewed in the context to the case, to the rules of the operating system used, and the application programs that created it. It's a combination of all three that determine the results. You could analyze the same data and it could change the results if the case context was just a little bit different. A good example. You have an individual whose job is to check malicious websites. You could have the same data, the same hard drive, the same sites visited, but that would be, let's say, pornographic. But because his job is just doing that, that result would be different than if you had, say, a help desk person that had the same sites visited, the same computer system, same date and times. Because his job is not to do that. Now it means something different, inappropriate web surfing more than likely. So once we have the analysis done, we jump on to the report. A report is basically the analysis summarized and in a sequence, in a form, and fashion understandable by the intended recipient of the report. In other words, you're writing it so that other people can understand it. Sometimes that may be different types of people. You may write a report, let's say, for attorneys, or another report may be for another computer investigator, which would be a lot more technical in nature. Then we go on to the disposition, the last step. The disposition of the data when deemed by policy or authority is the destruction of the data to allow the reuse or return of the media and the protection of the data if it was confidential. Examples that would be you're doing a financial crimes case and you have to return the computer back to the suspect. You would not want to leave all that financial data still on the computer system so he could continue the crime once again. So you would have, on a case like that, have to destroy all the evidence so it can not be seen again or used. One of the questions I always get in discussing the forensic process is, what about identifying the evidence? Well, when it comes to identifying evidence, that's an investigative function, and that's a whole nother class. So this is the end of the basic forensic process for hard drives. However, you can apply these same techniques and the information you've learned in this lecture to USB thumb drives, a USB drive, a multimedia card such as an SSD card, or even a cell phone if the cell phone is of the right nature and has the right operating system on it.